Hello, I'm Yarang Lee. The project topic I would suggest is zero-shot temporal action detection. So let me explain what this topic is. Simply put, the temporal action detection task is to predict the moment and type of action in a video. As shown in the figure, when an untrimmed video is entered as an input, it is to find the starting point and ending point where the action occurred in this video, and to classify what action this action is. And the project topic, zero-shot temporal action detection, is the process of detecting and localizing actions in a video without any prior training on the specific target action classes. Instead, the model relies on textual descriptions or attributes to recognize and categorize previously unseen actions. The goal is to detect actions that the model has never encountered before without the need for additional training examples or annotations for those actions. The project goal is to improve the performance beyond the baseline model, which will be explained in more detail later on. The dataset uses the Thermos dataset and consists of videos containing 20 sports actions. There are 200 trained datasets and 213 test datasets. The average action length is about 5 seconds, and annotations consist of the start and end point of an action and the type of action that occurs between them. The zero-shot action detection setting can be divided into two scenarios. In the first scenario, the model is trained on 50% of the actions and evaluated on the remaining 50%. Since there are a total of 20 actions, 10 actions are used for training and the other 10 actions are used for evaluation. In the second scenario, the model is trained on 75% of the actions, which means it is trained on 15 actions and evaluated on the remaining 5 actions. The data is randomly sampled in 10 different ways, and the evaluation metric will be explained later. The baseline model is stale. I will briefly introduce this model. First, to extract features from the video snippets, they use a frozen pre-trained video encoder to extract RGB and optical flow features at the snippet level. And for textual embedding, they use a standard clip pre-trained transformer with learnable prompt. And class-agnostic representation masking is conceptually inspired by mask transformer. They obtain a mask embedding for each segment as a query, then binarize this mask at a threshold and select the foreground mask. Given the binary nature of this foreground feature mask, this representation masking can be first optimized on scene action classes and further generalized to unseen classes. Then, in visual language cross-modal adaptation, integrating the descriptions of a visual context is likely to enrich the text representation. This module encourages the text features to find most related visual clues across the foreground snippets. And addition details is as follows. Video encoder is Kinetics pre-trained i3D model, and text encoder is pre-trained CLIP model. At the training stage, the frozen part is visual encoder, and the training parts are textual prompt embeddings, text encoder, temporal embedding module, and temporal masking modules. And this model is trained with 15 epochs with Adam. Finally, the performance is as follows. Lastly, let me explain the project goal again. If you choose this project, you can upgrade the performance to the base model described before. And zero-shot setting is 75% seen and 25% unseen dataset, and 50% seen and 50% unseen dataset, and zero-shot setting and action split baseline link is as follows. Finally, here is a link related to the dataset. If you have any questions, please send an email to contact information. Thank you.